time interval from 0 to 20? Well, our technique has been just calculate slope of the graph. Slope of an xt gives velocity. Do rise over run once you've created that triangle. So how much does this triangle rise? Well, it's between 40 and 60. These are 10-meter intervals, so this value right here is 50. So it has a rise of 50, and it has a run of 20. So I'll come over here. It has a rise of 50 meters, and it has a run of 20 minutes. These zeros can cancel. 5 divided by 2 is 2.5 meters per minute. And sure enough, that's one of our correct answers. Okay, I've always encouraged my students, don't even consider the multiple choice answers. Don't even look at them. Go ahead and solve it on your own. Come up with an answer and then look for it. Okay, it can be distracting to fill your mind with 3 wrong answers and try to look through that for the correct one. So solve it on your own first and then look for that correct answer. Good job if you got that route. Let's look at 7. Okay, in 7, Julie spent 3 hours hiking 6 miles up a hill, 2 hours hiking 8 miles down a hill on a different path. For Julie's completed hike up and down the hill, what was her average speed in miles per hour? So let's underline what we're looking for. What was her average speed? I'm going to come down here onto this paper and write so I have a little more space. So I'm looking for average speed or velocity average. I was given 3 hours hiking 6 miles up a hill. So that 3 hours is what we call time 1. Hiking 6 miles up a hill, that's distance 1. She spent 2 hours hiking 8 miles down the hill. So that would be time 2, would be 2 hours. And distance 2, okay, the distance she covered in that 2 hours was 8 miles. Looking for given, okay, what formula will allow me to solve for an average velocity? Total distance divided by total time. Now just solve. Okay, distance 1, 6 miles, plus distance 2, 8 miles, divided by time 1, 3 hours, plus time 2, 2 hours. 6 plus 8, 14, divided by 6. And let's not forget our units. This is total distance, which is miles. This is total time, which is hours. And then just go ahead and divide that. 14 divided by 6 is 2.3 repeating. So we'll just say 2.3 miles per hour. Okay, that was her average velocity. For question 7 for Julia. Alright, let's go ahead and move on to question 8. Alrighty, question 8. Andy rode his bike around Longview Lake at a speed of 15 miles per hour. How long did it take him to go around the lake if the path around the lake was 8 miles? First, identify what you're looking for. How long? Okay, we've determined that how long did it take. That means that you're looking for time. Okay, I'm looking for time. Next, let's write down what they gave me. They gave me a speed of 15 miles per hour. Okay, they used the word speed to tell me that, and also these units, miles per hour, are speed units. So I've given a speed equals 15 miles per hour. How long did it take him to go around the lake if the path around the lake was 8 miles? 8 miles is a distance. Distance equals 8 miles. Formula. If I'm looking for time, choose your time formula. Time equals distance divided by speed. Solve it. You just plug in your given values now. The distance was 8 miles, and the speed was 15 miles per hour. Those miles will cancel, and we've got 8 divided by 15 equals 0.53 hours. Okay, and that's the time. That's how long it took him. That's question 8. Question 9. Andy and John both left home at 9 a.m. Andy traveled 30 miles in 45 minutes. John traveled 20 miles in 30 minutes. Who traveled the fastest? Identify what you're looking for. Who traveled the fastest? That means we're looking for the speed. Now there are 2 people involved, so I need to know what was Andy's speed and what was John's speed, and then I can compare them and see who is the fastest. Okay? So let's start with Andy. Okay, I'll set up a template for Andy. What am I looking for? I'm looking for Andy's speed. What did they give me to find Andy's speed? Andy traveled 30 miles in 45 minutes. 30 miles, 45 minutes. Distance equals 30 miles. Time equals 45 minutes. Formula. If I'm looking for speed, speed equals distance divided by time. Solve it. Speed equals a distance of 30 miles divided by a time of 45 minutes. Again, this is speed of Andy, so we'll say speed sub A for speed of Andy. Speed of Andy is 30 divided by 45. And that's 0.67 miles per minute. That's the speed of Andy. Now let's do all this for John. Okay. Again, we're looking for the speed of John. We were given John's distance and how long it took him, or his time. John traveled a distance of 20 miles. Here's John's information. Distance of 20 miles, and it took John 30 minutes. So 20 miles took him 30 minutes. Formula, same formula, we're looking for speed. It's distance over time. Solve it. Speed equals a distance traveled of 20 miles divided by time, 30 minutes. Okay, and again, this is speed sub J for speed of John. And let's just do 20 divided by 30. And again, you could cancel these zeros. Some of you have memorized 2/3 is 0.67. So it looks like they both have the same velocity. Okay? Both travel the same speed. So this is correct answer would be B. Both travel the same speed. Okay, but you've got to go through quite a bit of work to figure that out. So, again, good job if you're able to calculate both of those correctly. Okay, question 10. The graph below shows the distance and time traveled by 4 cars. Okay, now again, I might not even read this question yet. I might just get acquainted with the graph for a minute. Okay, so let's see, okay, what kind of graph is this? The distance versus time graph. Okay, I've got all these different distances. It's in kilometers. My horizontal axis, I've got time. Right, I might think right away to myself, I remember saying in class that steep is fast and shallow is slow. So this car is going really fast up here because it's got a very steep slope. And this car 4 has a very shallow slope, so that's slow. Okay, now I read the question. What car traveled the slowest? Sure enough, it's car 4 because it's got a very shallow slope. Okay, let's just take a minute to just say, okay, what does that even mean? Why is a steep slope fast? Well, again, if you were going to turn this first line into a triangle for car 1, you can say, what was the rise on that? Okay, car 1. What was the rise? Well, it went all the way up to almost about 600, we'll say. Okay, so it has a rise of 600 kilometers. And car 1 had a run of, I mean, even if you said 2, just go ahead and say 2.5. Okay, and if you did 600 divided by 2.5, it's about 240, or it is 240 kilometers per hour. So that's the velocity of car 1. Okay, velocity of car 1. Alright, if you're going to do that for car 4, so for car 4, the rise on car 4 rises, we're just going to say it gets up to about 400. So it has a rise of about 400 and has a run of about 6. All right, so 400 divided by 6 is about 66.67 kilometers per hour. So if we compare this velocity of car 1 to this velocity of car 4, where this had a shallow slope, it's a slow velocity, versus car 1 that had a steep slope and had a high velocity. Okay, you weren't expected to do these calculations, but let's just elaborate a little bit on why a steep slope is fast and a shallow slope on an XT graph represents a slow velocity. Okay, moving on to question 11. Okay, question 11. Sarah left school and rode her bike home. The graph below shows the relationship between her distance from school and time. Alright, again, I might get myself acquainted with this graph. Alright, this is distance from school up here, so that must mean the origin is Sarah's school, because this is distance from school. This is time. Okay, I might say to myself, okay, there's 3 different types of motion here. This is positive and constant velocity. This is stopping, which is 0 velocity, and then this is continued motion in the positive direction. And it kind of looks like these are the same steepness. C might be a little bit steeper, might be a little faster. So let's move on. Which of the explanations could account for the section of the graph from time equals 30 to time equals 40, or section B? So here's time equals 30 to time equals 40. So what was happening here? We already said she had no motion. She stood at the same position of 1 mile from school, and she stayed there for about 10 minutes. So maybe there was a convenience store or a friend's house that she stopped at. Okay, this also has 0 slope, which means 0 velocity. So that means the correct answer would be Sarah stopped at a friend's house on her way home. Correct answer is C. Let's go to question 12. This requires a little bit of calculation. Emery rode his bike at a constant speed of 7 meters per second for 45 seconds. How far did he travel? Underline what you're looking for. I'm looking for how far. How far means distance. Okay? You can come right down here and write down your distance formula. Distance equals speed times time. Alright, now I know they have to give me speed and time. Speed equals and time equals. Let's find it. He rode his bike at a constant speed of 7 meters per second. Speed is 7 meters per second. The word gives it away, and also the units give it away. Meters per second, a distance per time unit is a speed unit. For 45 seconds. Time, 45 seconds. Solve it. Distance equals speed times time. The speed is 7 meters per second times the time, 45 seconds. Just calculate 7 times 45 is 315 seconds. Cancel. Meters. About 3 football fields. That's how far Emery traveled. Okay, question 13 is very similar to the John and Andy problem, where you've got to calculate the velocity of both and then compare them. So I'll do this one a little bit faster. A cheetah traveled 20 meters in 1.5 seconds, and a race car driver traveled 1,000 meters in 15 seconds. Is the cheetah or the race car driver traveling the fastest? So again, we're looking for how fast. And we know that speed equals distance over time. So the cheetah's information was given first, and the race car was given second. So we'll keep their information separate. Looking for speed. Speed equals distance over time. So the cheetah traveled a distance of 20 meters in a time of 1.5 seconds. 20 divided by 1.5 equals 13.33.